Welcome all. Today we are going to discuss the refrigeration system components. In the last lectures, what we seen about all year-round air conditioning system, then summer air conditioning system, inter air conditioning system, then central air conditioning system, unitary air conditioning system. Then again we saw the types of central air conditioning system, which are direct expansion type and indirect expansion type. Okay, today we are going to discuss the topic components of refrigeration system. So in vapor compression refrigeration system, what we see first, the component is compressor one, another one is the condenser, next one is the throttling valve, then evaporator, and again compressor one. So we are starting here from the compression one. Tomorrow we will take condenser, the next day we will take throttling valve, and next day we will take about the evaporator. So let's get started to study the compressor here. You may find the question in the examination that state the types of compressor and also draw the PV diagram of the single stage compressor. Both the topics are we are going to study today. So just take here the information what is expected to write about the compressor is that first, it is the major component of vapor compression refrigeration cycle. Then it increases the pressure of low pressure vapor refrigerant to high pressure vapor refrigerant. What is the function of compressor? Its function is to absorb low pressure refrigerant from the evaporator and increase its pressure, and then this high pressure refrigerant is passes to the condenser. This is the main function of compressor. Then compressor must be driven by prime movers. Actually compressor requires work. You see that during the efficiency or COP of vapor compression cycle, what we are doing, it is taking it as the COP is equals to refrigeration effect produced upon work supply. So where we supply work in VCR, we supply work to the compressor. Okay. Classification of compressor. First one is according to the method of compression. Then there are three types of compression. Compressor according to the method of compression. First one is the reciprocating, another one is the rotary, and third one is the centrifugal one. The first ever compressor you saw in your life, it is of reciprocating type. Where you saw reciprocating compressor, just tell me. We saw reciprocating compressor in while we are using that pressure pump of bicycle to fill the air in bicycle. Which type of compressor is that? It is reciprocating compressor because your piston moves the same path repetitively. So it is reciprocating compressor. There is a no rotor or no circular motion is there. There is a linear motion which is repeated one. So what we are saying here, this is the reciprocating compressor. Okay, then another one is the rotary compressor. Where you see the rotary compressor we see where you go to fill the air in your bike, two-wheelers. So where you can, there you see there is a more tank, and when he start the air compressor motor, then there is a fan is continuously start rotating, and this tank fills the air pressure in his tank, and through this tank we are filling the pressure in our tires. So what you can see there is a fan. So where you see the fans is used to compress the air, then it is rotary compressor. And centrifugal compressor is again another type of compressor where we are using the centrifugal force to fill the to increase the pressure of air. Okay, the next one is according to number of working stroke. First one is the single acting compressor, and another one is the double acting compressor. What is single acting compressor? You know that while filling the air in our tire tube, there is only a one stroke which is going to compress the air when you pull the piston from uh, top to bottom. At this time only the air is filled in the tire tube, so you can say that this is a single stroke, and another stroke is ineffective, or it is a suction one. But if both side the compression is going on, then it is called as a double acting compressor. Actually this is the advance in single stage compression. Okay, then another type is the according to the stages. So there are two stages: single stage compression and multi-stage compression. We already discussed this topic in single stage compression and multi-stage compression evaporator system. What we are going to do in single stage compressor, the only a single compressor is used to increase the pressure, but in case of two-stage compression, multi-stage compression, we are using an intercooler between these. Why we are going to use intercooler? To reduce the work supply to the compressor. So this topic is already we studied in chapter number 3 deep manner. So you know about this. Then there are two. Another type is according to the method of drive employed. Then there are two types of drive they employed there. First one is the direct drive driven compressor, another one is a belt driven compressor. This is according to the power supply. If we are going to supply power directly, then it is direct drive compressor, and if we are going to supply the power using the belt, then it is called as a power drive compressor. Okay. Then here we goes for the next page. The question you will see in the examination, that draw PV diagram of single acting single stage reciprocating compressor and explain its working. Suppose here you can see there's the PV diagram. This is the PV diagram without clearance, and this is the PV diagram of single stage compressor with clearance. Where you see the clearance, we see the clearance here. Okay, so the piston of your compressor like this, when there is no clearance is provided, at this time the piston just reaches the top center of the cylinder, and if clearance is produces at this time, the piston does not reaches to the top dead center, there is a clearance is provided. So you can see that this is the clearance is provided here. Okay, same clearance we are showing that here. Okay, so the other PV diagram without clearance, and this is the PV diagram without clearance. Okay, so you can see that compression may be a three type: adiabatic, isentropic, or polytropic compression. Here we are taking only isentropic compression. So just 1 to 2 is compression, and 3 to 4 it is the process of suction. Then what is swept volume? In case of with clearance compressor, this is the volume through which pistons moves up and down. So this is swept volume, and in case of without clearance, this is the total volume through which pistons moves up and down. So we can be stated it as a without clearance. Okay, discussing about the working of compressor, that in short we can say that during the suction stroke piston moves downward, and during the delivery stroke suction piston moves upward. Okay, how this upward downward I will be explain you in the next slide. Just look at it. Here we go. This is the diagram of the single stage compressor. I am showing here suction stroke. Then what is happening in the suction stroke? This piston, what is happening in the suction stroke? This piston is moving downward. Okay, just see here, this piston is moving the downward, creating the suction there. At this time delivery valve remains closed, and this inlet valve remains open. Okay, so through this air comes in, this valve remains closed. This is what? Suction stroke. And what is the delivery stroke? At the delivery stroke, this inlet valve remains closed. inlet valve remains closed and delivery valve remains open. So what you can say that high pressure air is passed through the delivery valve to the application where it is going to use. These are the two strokes, suction stroke and delivery stroke, which through which we are going to explain the working of compressor. I am again explaining that during the suction stroke, delivery valve remains closed, inlet valve remains open, and piston moves from upward top bottom center to bottom dead center. And what actually occurs in delivery stroke, this inlet valve remain closed and piston moves from uh, bottom dead center to top dead center, and delivery valves remain open at the end of stroke. Okay, talking about this construction features of the compressor, you can say that the construction components are piston, then cylinder, then it's crank actually it is mechanism, then this is inlet valve, delivery valve. These are the various components of compressor. Okay, then here we go. Again we goes to the PV diagram and TS diagram. That's 1 to 2 it is the suction process, and 3 to 4 is the compression process. Here we are leaving the clearance, here we are not leaving the clearance. Okay, now I am going to explain the working again related to suction stroke and delivery stroke. Just here to me. In suction stroke, when the piston moves downward, suction stroke, the pressure inside the cylinder falls below the atmospheric pressure. Due to this pressure difference, the inlet valve gets open and the air is sucked into the cylinder. The crankshaft is driven through a prime motor. In delivery stroke, the inlet valve and delivery valve are mounted in the cylinder head. The valves are present differential type. Valves are automatically open or closed depending upon the pressure difference between the outside and cylinder pressure. When the piston moves upward, delivery stroke, the pressure inside the cylinder goes on increasing till it reaches the discharge pressure. The discharge valve gets open and air is delivered to the container. As the piston starts its suction stroke, the air contained in the clearance space expands till its pressure falls below the atmospheric pressure. At this stage, the inlet valve gets open, as a result of which fresh air is sucked into the cylinder, and the cycle is repeated here. Okay. Then application of reciprocating compressor. Reciprocating compressor is used with refrigerant having low specific volume and high condenser pressure. Reciprocating compressor are used with available size ranging from 1 by 8 high pressure in small domestic unit to 100 high pressure in large installation. Reciprocating compressor can be used with refrigerant like R12, R22 or ammonia. Okay. Now we are going to see another type of compressor, which is screw type compressor. In examination you may see the question that with the help of diagram explain the working of single stage compressor with advantages and disadvantages. Okay, so here we are going to see these script type compressor. What the checker will expect, the diagram along with the explanation, advantages and disadvantages. Okay, so let's start with the diagram. What are the main components of the uh, screw compressor? This is the there are the two rotors can be seen here. One is the driver one, another one is the driven one, which is enclosed in a cylinder type, simply having one end as a suction and another one is the supplier one, or maybe it is a closed one. Okay, so screw compressor is positively displacement compressor, consists of two mutually engaged helical grooved rotor suitably housed in casing. Casing means it is a cover. Co casing, it is the cover of that particular assembly. On the one rotor is driving and other is driven rotor. As the rotor continue to rotate, refrigerant vapor is removed axially, radially get compressed by the volume reduction as interlope goes on decreasing. Compression of vapor continues till the discharge part is reached and high pressure vapor leaves through it. Okay, then comes to the advantages of this compressor. First one is the high volumetric, it is having high volumetric efficiency. Another one is that operation is quite and simple. Third one can be stated as uniform and continuous refrigerant is obtained. So this screw type compressor, it is superior to the reciprocating compressor, that's why it is founded. I am again going to read the working of screw type compressor in deep just here. Screw compressor is positive displacement compressor, consists of two mutually enlarged helical grooved rotors suitably housed in a casing. One of two rotor is generally male rotor is driven having four helical lobes which are engaged in corresponding fluid of female rotor. Female or driven rotor has 6 number of fluids. As driving rotor turns, refrigerant vapor are drawn in housing and fill the interlobe space. As rotor continue to rotate, refrigerant vapor is removed axially and radially and get compressed by volume reduction as inner lobe go on decreasing. Compression of vapor continue till discharge port is reached and high pressure vapor leaves through it. Uh, I am again listing the advantages of screw type compressor here. Thus, having high volume efficiency, the operation of this compressor is quite and simple. Uniform and continuous refrigerant is obtained. Absence of suction and discharge will eliminate pressure drop. It can be directly coupled to prime mover. It can be used with refrigerant R12 and ammonia. It is purely rotary motion, therefore it is perfectly balanced. Okay. Then another type of compressor which can be taken as a hermetically sealed compressor. This is also an important one which you can study it by your own. Hermetically sealed compressor, and then centrifugal compressor, just quite simple one, just to just overlook on it and prepare it on yourself. In the next lecture we are going to study the condenser, the types of condenser, how they are going to work. So until this, stay home, stay safe, and hope to see you soon.